Hello students, today we will solve numerical based on Mason's gain formula, that is signal flow graph. Okay, so this SFG can be drawn by different ways. You have to find transfer function from the signal flow graph. So here we are solving one numerical where equations are given. Okay, so in that equation you can check. See here, the formula for Mason's gain formula, transfer function is given as Laplace transform of output to Laplace transform of input. Okay, so summation of pi delta I is equal to delta, and here you have to find the transfer function from this given system. So you have to find transfer function x5 by x1. Okay, so it is given in the numerical that you need to find x5 by x1. Okay, so from these equations you have to obtain SFG. Okay, so how you will obtain SFG? First of all, you have to check for the number of variables. So how many variables are there? Look at this, starting from x1 to x5, total 5 variables are there, and these are all constant terms. Okay, a1 to a4 5, a5 to, these are constant terms. Okay, so we will draw SFG from the equations. So see here, I am considering 5 nodes with the label x1, x2, x3, x4 and x5 because 5 variables are there. Okay, now as we know that, suppose I am drawing like this, so here I am saying x1 as a label, so this is x2 and x3, and here label is given as suppose a1, a2. Okay, instead of writing x2 here, consider the label x2 here. Okay, so see here, suppose you have to write equation for these vectors. So how you will write? At node x1, 2 vectors are, or 2 signals are coming. So how you will write equation for x1? So x1 is equal to here gain into input. Okay, see, for this signal x1 is output, a1 is gain and x2 is input. Okay, because you have to consider the direction of the signal. So signal is always traveling from input to output. So for node x1, here 2 signals are coming. So how you will write equation for x1? You will write gain into input, that is a1 x2 plus a2 x3. Okay, so this is equation for the given variable. So similarly, we have to draw signal flow graph from the given 4 equations. Okay, so first of all we will start with the equation number 1, that is x1. So see here, I have considered 5 node. Now here x2 is there, so x2 is output. So for this output, how many signals are incoming? 1, 2, 3, 4. So 4 signals are coming at node x2. So I will draw SFG for equation number 1. Now see here, a12 x1. Okay, so this is gain into input. So this is input. So I will draw like this. Okay, so a12 x1. Now look at this, a32, signal is coming from 3 to 2. Okay, signal is coming from 3 to 2. So I am drawing 3 to 2 like this. Okay, so a3 to 2. Why I have shown direction like this? Because it is coming from output to input. The signal is not shown like a23, it is shown as a32. Okay, so a32 x3, then a42 x4, a42, again signal is coming from 4 to 2. Okay, so I will draw like this, a42. Okay, so a42 x4, then a52, third signal is also coming from 5 to 2. Okay, so I will write like this, a5 2 x2 x5, sorry. Okay, so we have completed with this equation number 1. Now equation number 2, x3 is equal to a23 x2. Okay, signal is coming from this a23 x2. Third equation, for x4 how many signals are coming? 2 signals. So look at this, a34 x3. So a34 x3, then a44, you can check that signal is starting from 4 and ending at 4, so this must be the self loop. So I will draw self loop with a gain like this, a44. I told you what is self loop. In self loop, the input and output node will be the same. Okay, now last equation, for x5 how many signals are there? 2 signals. So a35 signal is starting from 3 and ending at 5. Okay, so I have to draw like this, a35 x3. Okay, look at this, a45 a45. Okay, so this is signal flow graph from the given equation. Okay, now we have to solve this signal flow graph to get transfer function x5 by x1. What is x5? Output upon input. So now you will use Mason's gain formula. So for Mason's gain formula, there are number of steps. Okay, so here it is given that summation of pi delta I upon delta. Okay, so we will start with the number of steps here. Okay, so step number 1. Step number 1 is you have to calculate pi. What is pi? Pi is gain of forward path. Gain of forward path. Okay, so I indicate number of forward path. I told you what is forward path. Signal starting from input and ending at output is called as forward path. So in this SFG, how many forward paths are there? We will start with x1. Look at this, x1, x2, x3, x4, x5. So this is first forward path. Okay, so I will write like this, p1 gain of first forward path a12 into a23 into a34 into a45. So this is your first forward path. Okay, now check for the second. You can check here, these 3 signals are feedback signal. You can check the direction here. This is loop that we will not consider in forward path. So one more signal is there starting from x1. Look at this, x1, x2, x3, then to x5. So one more forward path is there. So I will write the forward path gain for second is a12, a23, then a35. Okay, so the second forward path for this SFG. Okay, now next step number 2, you have to calculate number of individual loops. Number of individual loops. Okay, so I will check for the number of loops here. Okay, so loops means closed loop path. So how many loops are there, that we have to calculate. Okay, so I will start with this. What is loop? Loop is a closed loop path where the input and output node will be same. Okay, so I am starting like this. Look at this. So this is my first loop. Okay, then again this will be my second loop, then this will be my third loop. Okay, and this self loop is a fourth loop. Now you have to check in SFG whether more loops are there. So yes, look at this. Here one more loop is there. Okay, so total 5 loops are there. So we will write the loop gain one by one. Okay, so look at this, L1 is equal to A23 into A32. L2 is equal to A233442. Next, L3 is equal to 23344552. Okay, then self loop. L4 is equal to A44. Then one more loop, L5. So L5 we just now have considered A2, 3, 3, 5 and 5, 2. A2, 3, 3, 5, 5, 2. Okay, so these are loop gains. So how many individual loops are there? 5 individual loops are there. Okay, so next step number 3. Okay, for step number 3 we have to calculate pairs of two non-touching loops. Okay, so now we will check whether there is any pair of two non-touching loops. You can check here. See here, we have considered this loop. This loop is not touching to this self loop, or it is not sharing any common part there. So I will write like this. This loop we have considered as L1. So L1 into this self loop. So self loop I have considered L4. Okay, so loop gain, it will be like this. Okay, now check, one more pair is there. Okay, see, we have considered this outer loop, this one we have considered this outer loop. This outer loop is not touching to this self loop. Okay, so one more pair is there. So I will write like this. Self loop pair is L4. Okay, and outer loop is L5, that is not touching to each other. So I will write like this: A2, 3, 3, 5, 5, 2, A4, 4. Okay, now step number 4, it can be group of 3 non-touching loops. Okay, but you have to check whether there is a group of 3 loops which are not touching to each other. Okay, so see here, there is no group of 3 loops which are not touching to each other. Okay, so we will not calculate, or no need to calculate step number 4. Okay, that is a group of 3 non-touching loops. If in any SFG there is a group of 3 non-touching, then we have to consider. Okay, now next step number 4, no need to calculate. So one more thing, we have to calculate this delta I. See, we have calculated Pi, we have calculated all the terms inside the delta. Now we have to calculate delta I. Okay, so what is delta I? Formula for delta I is equal to 1 minus in bracket. 1 minus in bracket. See, suppose I am calculating delta 1. Okay, so how I will write? 1 minus, I will check 1 for first forward path. Okay, I will check whether there is any loop which is not touching to this first forward path. I am repeating, what is delta 1? 1 minus in bracket, 1 minus in bracket loop gain which is not touching to ith forward path. Okay, so see, all loops are touching to this first forward path. There is no loop which is not touching to first forward path. Okay, so I will put here 0. So delta 1 is equal to 1 minus 0 is 1. Okay, now delta 2. See, since here 2 forward paths are there, so there will be 2 terms of this delta. P1 delta 1 plus P2 delta 2. So we need to calculate delta 2. Okay, what is delta 2? Delta 2 is a term related with the second forward path. Delta 1 is a term related with first forward path. Delta 2 is a term related with second forward path. Again, formula is delta 2 is equal to 1 minus. in bracket. Okay, so see the path for delta 2. What we have considered? We have considered second forward path like this. See, this is second forward path. Then check, this self loop is not touching. Self loop is not touching to second forward path. So what I will do, I will write here delta 2 is equal to 1 minus gain of, that is loop gain, okay, of this self loop, because this self loop is not touching to this path. Okay, so my delta 2, it will be 1 minus A44. Okay, so we have calculated all the terms. Now we will put all these terms in Mason's gain formula. Okay, so what is Mason's gain formula? Mason's gain formula is equal to, transfer function is equal to, now I am directly writing x5 by x1 is equal to summation of pi delta I. Okay, so I will write like this, p1 delta 1, as we know that two forward paths are there. Okay, so p2 delta 2 upon delta, but in delta I will write like this. Look at this, 1 minus in bracket sum of individual loop. Okay, sum of individual loops, plus in second bracket sum of two non-touching loops. Okay, and if there is a group of 3 non-touching, so I will put third bracket for 3 non-touching. If there is no term, so you will put there 0. Okay, so this is formula. Now you have to put all the values in this formula. So I will substitute all the values. x5 upon x1 is equal to, look at this, what is p1? P1 is this. I will directly put a12, a23, a34, a45 into, see, I have written here delta 2, it should be p1 delta 1. Okay, so multiply it with delta 1, so delta 1 is equal to 1. Okay, then plus p2 is equal to a12, a23, a35, okay, into delta 2. So I will write in bracket 1 minus a44. Okay, so this is your numerator. Now in denominator, we know that delta is equal to, just now we have substituted, so delta is equal to 1 minus in bracket individual loops. How many loops are there? So 5 loops. See here space is less. Okay, so I will write like this, L1 plus L2 plus L3 plus L4 plus L5. Okay, so this is your first bracket, 1 minus sum of individual loops. Next, plus sum of two non-touching loops. Okay, so there is a pair of two non-touching loops, so I will put the value here. So A23, 32, 44 plus 233552 into A44. Okay, so this is your transfer function. Okay, so what you have to do, you have to substitute value of L1, L2, L3, L4, L5, whatever we have calculated. I have not substituted because here space is very less. Okay, so I think you got the concept of Mason's gain formula. Okay, so see, I will revise again. For Mason's gain formula, if the equations are given, so from that equation you have to draw SFG. Okay, next step number 1, you have to calculate number of forward path and gain of forward path. Okay, step number 2, you have to calculate number of individual loops. Okay, so see, from SFG you have to calculate the exact number of loops. If any loop is missing or the number of loops are not matching with the exact numerical, then your transfer function will be wrong. Okay, then step number 3, pair of two non-touching loops. Again the same thing, you need to calculate the accurate pairs of two non-touching loops. Okay, If 3 non-touching loops are there, so there will be one more addition of step number 4. Then next, the important thing is delta I. So delta I is a term related with the forward path. So number of forward paths are 2. So there will be 2 terms of delta I, that is delta 1 and delta 2. So we will revise the formula again. What is delta I? Delta I is equal to 1 minus, in bracket we are checking the loops which are not touching to ith forward path. Loop gain I will write. Loop gain which are not touching to ith forward path. Okay. So if the loops are touching to that forward path, we will put 0 here. For delta 2, we have seen that in second forward path, this self loop is not touching. So we have substituted the loop gain here and we got the answer. And at last, we will rearrange x5 by x1. We will rewrite that formula. We have substituted all the values. Okay. So I think you got the concept. We will solve more numericals in next class. So thank you, students.